So the other thing I've got to do is this is that spacer that goes in behind the blade, and I'd taken it down previously and took the hash marks off of it and polished it up a little bit, but it uses a pin in there to drive that blade, and that had been broken off, and it's broken off down inside there. That pin is a 5/16, and I thought about drilling that out and tapping it for a 5/16 bolt, but this hole is already drilled out to 5/16 for that pin. So that really wouldn't work. There's not enough hole there to put threads in there for a 5/16. Now another option would be to thread it for 3/8 and turn the shank of a 3/8 inch bolt down to 5/16 and then cut it off. But that makes the edges of this kind of thin here. I've got to drill that pin out of there and put a new pin in, and I could just put a pin in and Loctite it in with some Loctite, or I can put it in like the other one was and weld it in. But whatever I do, I've got to drill that out. And that's broke off down inside there. It's got kind of a rugged edge on it in there. I could take an end mill and flatten that out and then center drill it. But what I did is I made a bushing. The bushing is 5/16 on the small end there, 1/2 inch here on the larger end, and then the hole was drilled out for number 21 drill bit, I think, either 19 or 21. So anyway, that will fit right down in there. That fits right down in that hole. And then I can take a drill and run down in there, and that centers the drill bit in this, and I can pilot that out and then take a 5/16 drill bit and finish it out. It'll follow the hole that way. So this I just turned out on the lathe, and that was just a piece of shaft off of an outboard motor that was scrapped out. That was part of the drive shaft out of an outboard motor. It's nothing special. It's not meant to last or anything, it's just a one-shot deal. So there we go. Okay, that worked. I guess I could have put that in there with some Loctite and let it seat in here better. It wanted to come out with the drill bit as I was pulling the bit back and forth to relieve the chips, but it worked, and I got my hole centered on that piece of metal in there and that shaft, which is what the whole thing was. Now I can take a 5/16 drill bit and that'll follow that hole down through there, and then I can put a new piece of rod in there for the driver. So that I'm happy with that. So that was just a piece of mild steel or whatever drive shaft for an outboard motor is. It cut pretty easy. If I wanted to make one drill bushing to do more stuff, I'd probably make it out of drill steel or something and harden it, but that worked for what I needed. Meow. Meow. Come here. What? Come here. The chicken is too hot for you to eat. The chicken is too hot for you to eat. Oh, there's Mouse. You smell it too, huh? You guys want a little bit of that chicken? Well, it's not done boiling yet, or it just got done boiling, so it's not ready to eat yet. We gotta wait for it to cool off. Yeah, gotta wait for it to cool off. Yes, you too, huh? You too, huh? Alright, I'll go get some out and let it cool off for you. We get scraps that we cook up on the stove out there for dog food to mix in with the dog food to supplement it. And we get fish and chicken. My wife gets lots of chickens from the grocery store she works at there. So we got a pot on there, fresh stuff that she just cooked up, and cats come outside and they could smell it. They weren't happy until I went out and got them some, but we just boiled it up so it was kind of hot. I had to go take it out and put it in the snowbank for a second. Now they're happy. We got this block here. This is the bushing that goes behind the blade. So I made up this drill bushing guide and put in there to use to center the drill, a pilot drill on that hole, and drilled that hole out with a, I think it was a number 21 drill bit, 19 or 21 drill bit. Drilled all the way through it, and it went pretty good through there till it got out on this end where that weld was in there, and that weld was pretty hard, but we punched through it. And then once I got that hole piloted out, then I took a 19/64 drill bit and drilled down through there and drilled the rest of that stud out of there, that shaft out of there, but it just left a little rim around there. And then I took a 5/16 reamer and reamed that hole out So that is taken care of. And then I took a countersink bit and just deburred this hole here where it goes down in there, because this is the face I want perfectly flat, and it goes up against that saw blade there, and I want it perfectly flat. And then in this side I reamed it out with the countersunk. I countersunk it out quite a bit, and we'll use that to weld in that stud when we put it in. So that's ready to be fixed with a stud in it. So I was thinking about what I was going to do for a stud for that, for a pin for that, and I'm trying to figure out what I was going to do, whether I should turn something down off a piece of steel that I got, or check and see if I have some 5/16 inch rod. I thought, well, maybe that stuff's a little bit soft, but it's probably all right. I think that's probably what was in it, was just 5/16 inch rod. And I was wondering whether I should buy a piece of 5/16 drill rod to cut and stick in there, but that might be kind of hard. And I thought, well, shoot, I can go down and buy a grade 8 bolt and cut off and stick in there, and that would work pretty good. So that's what I was planning on doing. And then I got to thinking, well, I got all kinds of hardware around here that I take out of the airplane. And so these bolts are CAD plated for corrosion resistance, and they go into aluminum. These are steel bolts, and they go into a lot of aluminum fittings and stuff, and some steel fittings on the airplane, but a lot of aluminum fittings. Well, anyway, whenever the CAD plating gets off of them, the CAD plating is the sacrificial plating on there. The cadmium is the most active material there between the steel and the aluminum. So when the CAD plating starts going and you start getting rust on there like that, and you see it on the shanks and stuff like that, then I take those bolts out and I replace them. Well, a lot of the fittings on the airplane are, well, like I said, some of them are steel, but they're all welded in, and a lot of the fittings on the floats are aluminum. You get the CAD plating off the steel and the steel against the aluminum, then the aluminum becomes sacrificial, the most active material there, and it'll start swelling up and corroding. And of course you got to use extreme measures then to get them apart, to get the bolts out of there, because everything all swells up with between the rust on the bolt swelling up and the aluminum swelling up and everything else. It takes extreme measures to get everything apart, but winds up ruining the aluminum parts. And those pieces on there, those float attach fittings, some of those can cost $500 or $600. So I'd a whole lot rather replace a $5 or $10, sometimes it's a $20 bolt, than to ruin a $500 or $1,000 part on the airplane. And then some of the parts, like on the wing roots and stuff like, or the wings and stuff like that, if I have to take those out because they get rusted out, then it's a whole big deal ripping the fabric off and welding in a new piece and refabricating, and it can be a pretty extensive repair. So anyway, like I said, $2, $5, $10 bolt is a whole lot cheaper than doing some of the repairs on them. So a lot of these bolts are perfectly usable for other things. Even this one has got a lot of rust and corrosion and stuff on it. This must be zinc plated. I don't know whether that was paint on there or zinc plating, but I think it's zinc plated. The good ones are CAD plated, but now the cadmium they can't put on there anymore because of hazmat. Although it's a lot more hazardous to my health if one of these things breaks than you get from the cadmium. But anyway, to get a bolt like that, it's still usable for some things, but not for the airplane. So I save these out in case I need them for something else, a pins or a bolt for putting something else together, whatever. Well, anyway, I got to thinking, I've got a whole bunch of these. And a grade 8 bolt, I think they're about 80,000, 85,000 PSI on there, rated at. And these aircraft AN bolts are not as strong. They're only 71,000, I think, or 72,000 PSI rating. But that's perfectly acceptable for probably way stronger than what I need for here. So I went over and got to looking through my stash, and sure enough, I've got a number 5 AN bolt, and number 5 is a 5/16, and that will work just perfect for this. So I can cut the head of this off, and I just went over and measured the thickness of the saw blade, and the saw blade is 0.177. So if I can measure this out, I'll trim this head off of this, weld that bolt in there, and have this extend out 0.177 inches for the pin, and we'll be good to go with this. I'll probably weld that up on here and then go ahead and turn that down flat again. This is the spacer that goes on the main shaft that drives the saw blade. This goes between the bearing on the shaft and the saw blade itself. Well, it's got a key here that goes in a keyway on the shaft, and then it's got a pin that sticks out right here that goes in a hole on the blade. I drilled that pin out, cleaned that hole out, and then I needed to make a new pin. Well, I had a 5/16 and AN5 bolt that I turned down the head of, and I was going to use that for a pin. I didn't turn down the bolt itself, I just turned the head down to the same size as the shank on the bolt. But when I put it in this hole, it was just a little bit sloppy. So I took an AN6 bolt, which is a 3/8 bolt, and I turned it down to where it just was a tight fit in here. It didn't fit all the way in. So I took this spacer and I set it on the wood stove and got it good and hot, and I polished up this shaft and stuck it in the snow. And this spacer was good and hot, and that pin was cold, so I dropped it down in there, and it went most of the way in. I just had to take the hammer and just knock it in just a little bit. But that looks like it's going to work now. I've fitted that pin in the hole on the mill, and it fits in there pretty good. So that pin is in there. It should be shrink fit in there. But I'm going to go ahead and weld it on the other end. It was welded in there before the pin was. But I didn't really like the way the 5/16 pin fit because it was a little bit loose in the hole. So this one I've turned down to a fit on the end here where it sticks out. I've got it just about the right length to where it fits in the blade. It should fit in there fine. I might have to trim that down just a little bit. I don't want it to stick out because then the collar that fits on the other end won't fit tight up against it. But this end here is a little bigger than the 5/16. I don't remember, I measured it and I don't remember what it is now, but it's a little bigger than the 5/16. It just does a shrink fit in there. So that would almost be good enough the way it is, but we like to be more than good enough, so we'll take this and weld that up in there and then turn it down so it's trued up again flat on this face. Well, anyway, it's still a little bit hot, so we'll let that cool off and take it back up to the basement where the welder is. I've got a few other pieces here that I'm going to be welding on too, and I've got a couple other pieces here I've shown before that where the holes have hogged out on them over time that I'm going to weld those pins up, the pinholes up. So those will all be taken up to the shop and welded up there. Well, I guess I better get some of these stuff patched up that I was planning on patching up the holes on. I've got to weld this stud, this pin in this collar here that goes on the main blade, that drives the main blade. And then I've got some holes here that are elongated in a couple of these parts I wanted to fix up. So I'm going to have to finish up on there, get this stuff done and put away for a little while because it's time to start working on the airplane, get it ready for the spring season. It's actually the 1st of March, 2nd of March today actually. Well, I need to start thinking about getting the airplane ready to go. Well, I've got my Harbor Freight welding table out, and I bought it Harbor Freight, of course, and I've got my Everlast 210 TIG stick welder out. I've got it set up for TIG welding, of course. We'll go ahead and see if we can't work on this stuff. Now, it's been quite a while since I've done any TIG welding. I probably should see if I can find a piece of scrap or something here, something to run a couple beads on just to get. There we go. Here's a piece of steel square tubing here, and I can just put that on there and just use that to get myself set up and the machine set up. Well, it took me a little bit of trial and error, but I got it figured out and got these pieces patched up, the holes there filled up in those things, and then I welded in that stud there, that pin. Well, I'm going to go ahead and take that and put it on the lathe and turn it down and smooth that out, but it's not too bad. It's not near as bad as what what the original was. So anyway, he said it took a little bit of dinking with it and stuff to get it figured out. Dipping my rod a little bit, sticking my tungsten, but we got it. So I can clean those up, re-drill those holes. We'll powder coat those, and those will be done. This bushing for the main drive blade, this has got the pin in it for the drive on that main saw blade. I got it all cleaned up. I welded that pin in from the back side here, and then I just turned it down on the lathe again just to make sure everything was all nice and parallel. These two sides here were parallel because this side goes up against the saw blade. This side here, the outer portion of it doesn't do anything, but the inner portion of it rides on the bearing. So anyway, I got that trued up again. Well, that's ready to be powder coated, to be painted. And these pieces here, I got those holes filled in. Well, I'm going to take the die grinder now and grind those welds down and get those re-drilled, and then we can powder coat these parts too. These pieces are all powder coated, all done. This is one of them that the hole was elongated on, and I welded it up and filled it up and then re-drilled it. This one here, there was 2 holes in it. No, there's just 1 hole in this one right here that I filled and re-drilled. This one had 2 holes, this one here and this flange here, and in this one, and I think this goes like this. Tight in there now with the powder in it. Oh, there it goes, just like it's supposed to. Okay, so that'll have a bolt go through there to hold that on there, and then this gets all the pulleys and stuff on it for adjusting, reversing, and forward on the carriage travel and whatnot. Oh, that's a lot nicer there. I got the 2 lumber gauges. I cleaned those up. Some of these pieces, like this handle here, I drilled a little hole, an 1/8 inch hole in it, and this one here, so I could hang them for the wires. So this one here is I couldn't hang it down like this, so I drilled a hole in it here on this end so I could hang it up like this. And this one already had enough holes on it. This is the handle that adjusts the speed, that adjusts the variable speed pulley. This one I'm going to have to do something with, because this is one I talked about that didn't like it because you couldn't take it apart to do all the pieces. And so this is where this angle iron piece was sitting here like that, and it of course doesn't have any powder on it. Oh, I'm going to have to see what I can do about that. It slides up and down on it nicely. It doesn't bind up on the paint any, so there's plenty of room in the hole. So that worked out good. And here's the drive bushing. That's all finished now. This is where I welded that pin in. I'll probably have to scrape all the paint off of the pin, but that's done. So these parts can go up and be put away. I started to put some pulleys in some of these. Oh, this one here can get pulleys in it. This one here, or not pulleys, but bearings. Anyway, some of this stuff can go together. Like I said, I have to figure out what I'm going to do with this to cover that up. And then while I was waiting for that stuff to cook, I put this, I got a hacksaw and cut the flanges off on that. So I got those down. Now I have to get a grinder and grind the rest of this off of here. But anyway, I think that's about all I'm going to do for a while. I've got to start working on the airplane to get it ready to go. I start flying in the middle of April, and it's the 1st of March here now, so I've got to look at it, and I've got to get a hold of a guy that's going to come and do the annual on it, and I've got to get a couple other things ready for it. So anyway, I just got to start getting that stuff lined up. So this is all going to be on hold for a little while. But yeah, that looks pretty nice there. A little bit of a spot here where the string was on it, the wire was on it, that didn't get coated, but otherwise it looks pretty good. And all the rest of these look really good. Orange. Orange is the new black.